Hello everyone, this is Helen Allen from STAT699, and in this video we're going to learn how to calculate z-values or z-scores. Now remember, we're working with numerical data, and when we calculate z-scores, we standardize normally distributed random values to a standard normal distribution, and that mean is 0 and the standard deviation is 1 in the standard normal distribution model. Now our z-score tells us how many standard deviations our value is from its mean. And our formula is fairly basic. X value minus the mean divided by the standard deviation. So to get a better understanding of z-scores and z-values, we're going to calculate and analyze the z-scores of the wait time experienced by patients in a dentist's office. And if you take a look at our A column, you'll see the X values, which are the wait times in that A column. So the first thing we're going to do is calculate the mean. So I've clicked on cell C2, equal average for the mean. Our array is A6 through A20, close the parenthesis, plus enter. So our mean is 10.546. Now I'm going to calculate the standard deviation, equal STDEVA, A6 through A20. Press enter. And our standard deviation is 4.232. So I'm going to click on cell B6. We're going to calculate the formula. Our X value is 10.22 minutes, and that is in A6, so equal. I'm going to open my parenthesis, A6 minus our mean of 10.546. That's in C2. I'm going to lock that in because that value, the mean and the standard deviation, are going to be included in every single formula that we calculate. So sorry about that. $C, $2, close the parenthesis, divide, and C, $3 for our standard deviation. Press enter, and we have a value of negative 0.077, and what this means is that a 10.22 minute wait time is equal to negative 0.077 standard deviations from the mean of 10.546. So we're going to just drag that number all the way down. We've locked in our mean and our standard deviation, and all of the z-scores populate down next to their X values. We can also use the standardized formula to calculate z-values or z-scores in Excel. So that's equal standardize, and our A6 is that 10.22 wait time, comma. Our mean, again, we lock that in, $C, $2, comma, and then it's asking us for the standard deviation. And then $C, $3, and we close our parenthesis and press enter. And as you can see, we put commas between the X value, the mean, and the standard deviation, and those of course are enclosed in parentheses. So we get the exact same value, and we just populate that all the way down. We just drag it all the way down. So now we're going to analyze our z-scores, and what we want to see are values that fall between -3 all the way up to +3. Anything beyond that are considered outliers. So we're going to look at all of our data points, and you can't see all the data points at the moment on the screen, to see whether they comply with this -3 through +3 range. So when we take a look at our outliers, we see that there is a data point that is 3.085 above that +3 number. It's a 23.6 minute wait time. So we need to investigate why that happened. Is it a simple mathematical error, or was it that the dentist experienced an emergency and so one of the patients had to wait? Whatever it is, we have to determine what we're going to do with that data point. Sometimes we take it out of the data distribution, and sometimes we leave it in, but we have to have a reason for that, and we're going to note that. I'm also going to show you that had we created a histogram with those X values, that outlier, that 23.65 extreme value, would have shown up on that histogram. So it's always a good idea for us to create our histograms. It also brings up an interesting trait about z-scores. The data shape of the z-score remains the same as it was prior to the standardization. So the data shape remains the same after the z-score is calculated. So it's an interesting characteristic of the z-score. Another interesting characteristic is that the z-score is metric neutral. So we can compare variables that are measured in different units. For example, we calculate the z-score of a house that is priced in US dollars. So we calculate the z-score of the prices in US dollar, the price in US dollars of the house. We compare that z-score to the z-score of the house's square footage. And we may detect a score that indicates that one of those variables is common and or one of the variables is atypical. We can also determine relative value of a grade or rating as part of a z-score analysis. So if you receive a 90 in your STAT midterm and you receive a 90 in your organizational management midterm, those two, the relative values of those two grades may not be the same because the mean and the standard deviations of each grade are different. And you can use the z-score or the z-value to find the probability that the z-score or z-value is more than or equal to or less than a specific value. Now in Excel we have a specific formula that allows us to kind of bypass that. You would use a table to, you calculate the z-score and then use a table to find the probability. But with an Excel formula we don't have to do that. But that's another trait of, or way you can use the z-score. So as you can see, calculating the z-score is easy. If you have any questions at all about anything, including the z-score, please don't hesitate to contact us. And we look forward to working with you in the classroom throughout the semester.